other questions? So I'm sharing the module 2. Okay. Okay, so if no questions, let's get started. So, okay, so for module 2, so we're switching to something completely different, right? So that will be Python. And we'll cover the very fundamentals. You know, like we'll essentially use two libraries, Pandas and Seaborn, which will give you enough power to download the data, clean it, change it, wrangle it, you know, like put it in the format you need, and then visualize it, which is very essential. Okay, so that's module 1, which we just finished. Right, so you know, like that's your choices. You have Python, you have R, C, and so on, and you know, like and the same like Unix and Bash scripts. So every language has its power. For example, like C++ is a great language for very complicated and heavy, computationally heavy tasks, but probably not the best idea for you because you're not developing the program, right? You're not developing the bioinformatics tool. If you would use C++, but not in this case, right? R, I would say just alternative for Python, and we'll have a little bit of R. Like personally, I prefer Python for various reasons, and this is what we do in our lab, Python for most of the things. For R, I think the advantage of R, you have some packages already developed for R, and I think it's more rich than the Python in sense of packages, like Bioconductor. There is very many packages which can do different things for you. So R in that sense is essential, and that's actually exactly the reason why we're gonna do R when we're gonna analyze gene expression data, because there is a good package for that. There is a package which will tell you which genes are differentially expressed across the conditions or the phenotypes, and we'll do some statistical analysis for you. So rather than writing yourself the Python code, why not to use R package if it's like good and available and recognized as the accurate one? So I think you, as you can see, you need to have some flexibility, right? In the sense that you need to know probably few languages to some degree. Maybe you need to, I would say you need to be proficient in one, right? Like very good in one language, but the rest you need to know in case you need. Okay, so like for example, for Unix, if you're doing raw analysis of the raw, like for example, we run Moldovan genome project, right? Let's say we recruited 100 people across the country, we got raw data. We cannot do it in the Python, right? Like if we want to analyze the bioinformatics, like the raw sequencing genomics data from those individuals, so we need to use cloud or the cluster, and you need to know Unix for that, right? For example, but let's say when you do the figures for the paper we're gonna publish about Moldova Genome Project, then you need to use Python perhaps, or R, but Python I would prefer Python. Okay, so as you can see, you need to have some diverse skill set to accomplish the project, right? So like if you think about the project from the very beginning to the very end, which is, I mean, to me, very end of the project is publication, right? So if you think about that, you need diverse skill set to be able to do that, right? And this is what we cover in this class, like very essentials of those skill set. All right, so that was Unix. But then we will talk about Python, and again, like later on, we'll talk about R. Okay, so I think it's what nice about Python. I don't know, I'm not sure if you saw the trends, but it's kind of interesting to observe across the years how the different languages gain popularity and actually lose popularity. I think Perl is a good example. So there is such a language, Perl. It was quite popular, I don't know, maybe 5-10 years ago, but then I think it's decreasing. And the Python is increasing dramatically. So because it's very user-friendly, with very small amount of time learning it, you can do things, and then it's very high level. So what is the advantage being very high level and be able to write things in a short, like, you know, like not writing a lot of code to do things, like meaning there is already libraries for you to do things, which turn out to be its weakness in some sense. And the weakness is that it's not that effective, right? Again, if you're analyzing if you're writing the bioinformatics tools, you can do it in Python. So, but probably it will be a little bit slower than C++. But again, that's not a concern for you. But Python is a great language to data science, absolutely. For data science, to manipulate the data, to download the data, wrangle the data, manipulate the data, visualize the data, absolutely. Python probably, I mean, my favorite. Okay. So we'll talk about introduction to Python, then we'll talk about how we can extend it with certain libraries, and then we will talk about tabular datasets with Pandas. So Pandas will be our library we're going to use, and we will talk about the files, which essentially are the tables, right? You can all like Excel tables in some sense. So we just delimit them by comma, right? That will be CSV. C stands for comma, C comma delimited format, and then and we can also delimit them by tab. So there is such a character tab, which is similar to space. But essentially, that's a table. So you have rows and you have columns. That's what is essential, right? So that's a very typical format. The one we will probably 99% of the data in the world, or like simple statistical data, is stored, right? So we're going to use that one. Okay. So why we choose Python? A little bit more about that. So because it's popular. So why it's important to stick what is popular? First of all, there is a reason behind why something is popular, right? So you can just follow the crowd and kind of do a right choice sometimes. But in this case, also it's very important that it's popular because there is a lot of resources on the web, right? Like which can guide you. So sometimes when you write the program, you can Google certain things and get the pieces of the code. I do that occasionally. Like why write something? Then like you can just Google and take the pieces. That's fine. That's a common practice. I mean, you need to adjust them, you need to understand them, yes. But sometimes it's faster to get the pieces. Yeah, and then it's powerful enough to do data science, but it's also easy to write. That's very important. It's easy to write. Okay. There is some stereotypes happening. So this one stereotype number one, Python is for programmers and R is for statisticians. I would say that's not true. I mean, they more or less has the same functionality. They have a different style of writing. I think Python is more formal from computer science perspective, and R is less so. But I think it's interesting to see that R gained the popularity, I think, due to the community. So the community around R is very supportive, and then the message is like, you can do it. You know, it doesn't matter who you are, with what background you're coming, you can learn R. And many people in, like, let's say from with the medical background, with the life science background, at least in the US and Western Europe, they learn R and then they produce the figures for the data they analyze. So I think that's what I anticipate you guys to do with the Python. So now I would say Python, so this is, I would say that just a stereotype that the Python is for programmers. I think some fraction of the Python maybe is for programmers, but what we're going to cover here is not more complex than R. I would say even less complex. And then definitely, to me, when you write the code in Python, for example, doing the good box plot, which can go into your publication, probably Python will take less lines. You will have like, I don't know, 4 lines, 5 lines, you will see maybe 6 lines, and you will get a decent box plot, which can go directly into your publication, which I think is pretty good. So you don't need to remember much, like 6 lines. I mean, you don't need to remember that actually. You just need to understand them and then copy paste them and utilize, right? So I think, again, it's not about the class, is not about like memorizing things, but rather understanding them so you can like reuse them for your purposes. But ultimately, I think whatever you do in Python, you can do in R and vice versa. In general, Python is full programming language and can be used across computational tasks. So here we are just using Python as data science tool, but not development of the tools. Okay. So, so we'll cover fundamentals, what is data types, variables, Python functions, and some additional Python operations. Okay. So actually, to run the code in Python will be exactly the same in Collaboratory. Google Colab will be exactly the same as you did for Unix. So then you're already prepared for that, right? You have a Collaboratory installed, things are working. The same idea, absolutely. And then I think you can combine. One cell can be Unix, another cell can be Python. And by default, actually, Google Colab is the Python-based notebook. So it's designed for Python. We just repurposed that to use Unix. It just happened to handle Unix, but it's designed for Python. So if you write your first notebook in Python, what you will do, you will just print. And that's a common tradition in computer science, just to say hello world, right? That's the first probably line of code everybody's written. So you say print. There is a special syntax here, as you can notice. Follow the syntax very precisely. Hello world. And what will happen, that's your cell with the code, right? The output will be just what you expect, hello world, like that line. So if you say hello world and something else will be printed, right? Like whatever in red, you can put anything you would like. That's your sentence to print, right? But print should be written exactly like this. Okay, so that was our first Python command. Okay, so fundamentally, again, Node will not go that much details here, but we'll try to tell you several fundamentals here. So there are integers, numbers without decimal points, 1, 2, 3, and 5, and so on. Then floating point numbers, floats, number with decimal points, like 1.0, 2.00, 3.5, and so on, right? That's like strings. So strings are just, like letters. So, and Boolean, meaning if somebody is true or false, right? So I think that should be enough in terms of the data type. So, and then you should understand fundamentally what you can do with things. With the integers, you quite can do a lot. You can combine them. You can say how much this integer plus this integer, and you can get like 1 plus 2, 3. That's great. But in the same with the floating point, you can subtract them, you can add up them, multiply. You can actually compare them. You can say, oh, what is larger, 1 or 2? And you know the answer. With the strings, you can do much, much less. With the strings, I think you can do pretty much say, is this string equal to this string? Right? You have one string, one set of letters, and you have another set of letters. You can add the same. Basically, added the same words. And then yes or no. Actually, the answer will be yes or no, which by itself is a Boolean variable, right? Like the true or false. And that's it. You cannot say this string is larger than this string. I mean, formally from computer science language, you can, but there is no much meaning in it, like in daily life, right? Like strings. So in that sense, you should understand fundamentally, when you do start with your data, which was given to you or you generated it, be super clear what is the type of each column and what can you do with that. Obviously, you cannot make a sum of the integer plus string. No, you cannot. So, and with the Boolean, it's just true or false, right? You can have some column, let's say, saying, I don't know, was this individual, let's say you have rows individuals, and the column says, does this individual have a certain disease, true or false? Sure, that can be this kind of column. Okay, so what is variable? So variable, this is where you store the value, right? You can imagine that like a box. So you need to put the value there. You have a bunch of, like when you run your analysis, sometimes you want to remember things, right? Like even do it manually, right? You write on the paper, you do a lot of calculations, say, oh, I need to know this number. You write it. So we cannot write, right? Like computer cannot write, so it will store it. So it's like you have a bunch of boxes when you write your program, and you can call them whatever you would like. You can call it like variable 1, variable 2, 3, 4, A, B, C, like anything. And they will store something for you, which you can utilize later, right? When you need it. You say, oh, suddenly I need variable 1 for something. Oh, I know, it's in the box. Let me take it, right? So in this case, you can see we are storing 1, which is integer, 1.2, which is floating number. 1 actually is a string. So the string, you can see, it's written in the double quotes. And then sometimes, usually it's highlighted in red, in the program. And then you have true. So true means like Boolean, right? Like true or false. And then it's highlighted in blue. So colors are helping for you, right? It's helping you. So when you write your program, if the colors are messed up, like if things are like all over the place with the colors, probably you get a mistake, right? So colors are also helping you to write the good code, that they need to be meaningful. Okay. Yeah, and you can name variables almost anything, like almost any strings, any letters usually. Okay. So there are some complex data structures. There is a list. So if you want to have multiple variables, right? Oh, I'm sorry, multiple values. So you want to have a box, but in the box, you don't want to put a single number. Instead, you want to put a lot of numbers in the box. Sure, you can. That's called a list, right? So you will put many, many things inside, and this is the syntax you will use. So you'll say 1, 7, 9, 15, 22, 31. And that will be your list. So that's the same variable, but just the type is different. It's a list. Now, usually you don't want to combine the list of the different types. If the list is integers, everything needs to be integer there. That's kind of like, otherwise it will be very confusing for you. I think technically it might be possible. I'm not even sure, but don't do it. Like it should be one type. And that, let's assume it should be one type, because it's just easier to interpret them. Now, so you print, and then you can print the list, right? So to like actually in Pandas, I'm sorry, in Jupyter Notebook, you don't need to say the print. You just say the name of the variable, and you will see the output like this. So that's your list. So this is called definition, right? You have defined the list, right? You say, I want this variable to be, and you say what? And you can say whatever, as many numbers as you would like. In this case, 1, 2, 3, 4, 5, 6. We said 6 numbers. You can do more, you can do less. Okay, so that's the list. Okay, so there's another type, which is another like data structure, which is some information about, let's say, patients. And then I will see. I don't think we'll use it much, but we'll see. I mean, it's good to know, but okay. So it's a little bit more complex, I would say. So basically what you have, so this is like the dictionary. So the dictionary is an ordered collection of the key values pairs. So you have the key and the value. So in this case, so the value of dictionaries can contain anything, number, string, function, whatever. So now let's see the example. I think the best is to explain by example. So what we have? So we have first name, last name, age, blood type, right? So, and then, so then this is how we can store patient information. So I would say, yeah, so that's the good way to store it. So just because you can have a key, let's say that you decided the key to be the name, and then, or something else, like, and then you can then search the people by name and so on, right? So, and then basically you have a key, which will be, say, the last name, which is the most unique, and the rest will be associated with that, right? So that's why it's the key and the value. The key is something you want to identify information, and the values is some important information for you. Okay, so don't maybe pay attention yet much to the syntax. Try to understand only the concept. And the concept is just that, like the concept is that, oops, sorry. The concept is that, wait, it doesn't go down. Oops, I need to go back. Okay, so the concept is that you just have key, which is to identify, and some values. Okay, how about this? Okay, so let's keep it for now. I think it's like we can listen. So I will say, Cynthia, I think that's a little bit too much. No, I would rather. So, okay, so good to know, but like, let's see if we can, should we use it really in this class or not? Okay, so let's focus on the pandas, because I think pandas is extremely important and extremely essential. So in order to use Python library, you must, so one thing is like about the library, right? So language comes with the libraries, and libraries are collection of the tools to help you, or commands and so on, right? Just to help you and make your life easier. So you would like to use it because it all simplifies your life. Okay, so in order to use Python library, it must be installed and imported. And luckily for you, that's already done in Google Colab. Okay, so an important statement is just import. So to import is meaning that you would like to say, I would like to use this library, and then you say, I would like to import it into my code. And then you will say, for example, import pandas, which is the name of the library, SPD. So why SPD? Meaning that every time you want to access a function from that library, you will say PD. Okay. Okay. Now, I would say when you import the library, it's a good idea to do it in one block of the code. So designate one block of the code and import all the libraries you need. Don't put it later. And maybe do it in the very, very beginning of your program. When you start, just like do it right away. And then obviously you should do it before you are calling the library, right? Like before you're using that, you need to import it very, very fast. That's why I'm saying like do it in the very beginning of your program, and then probably if you do anticipate to use that library. Okay, so if again, that's kind of optional information. So if something is not installed on the Google Colab, then you would need to install it. That's one way to do it. Okay, so again, let's don't pay. I mean, we're not skipping this, but rather like let's assume everything is installed for now, like for simplicity, because it is majority of the things I think you will be doing, they will be installed, and if necessary, we'll come back to this. Okay, so now the data is essential, right? It needs to be in the format, like expected format. So if the format is tabular, meaning that there is rows, and the columns, right? You can see here there is rows, and then there is columns, and you have some information about. I think this is the samples, I guess, name of the sample, and then there is about sequence, some information about sequencing. No, sorry, I think this is it the genes? I don't know. So there is some information given to you, and then you have, probably transcript per million. Yeah, probably those are the genes. So you have genes, every row is the gene, and then you have length of that gene. Then you have some expression number, which is TPM, transcript per million, doesn't matter. And then you have number of reads. So some information, right? So you have columns, which have names, and you have rows, which don't necessarily have names. You can add names to the rows, but usually we don't. It depends. So that's your Excel table, right, in a sense. So now what we want to do, we want to give you the skills so that you can analyze this kind of table with Python rather than Excel, right? I think that's to put it simply. Okay. So Pandas. So extremely important thing, extremely useful. It's a software library, right? Like it's a library which gives you a collection of the functions, which makes your life basically easy so that you can use a variety of functions to analyze your data. One very important concept is the data frame, which holds the data. So when you analyze the data with Pandas, you should read the data first and store it, save it as the data frame, okay? So basically, data frame will be very nice structure where you will have rows. Will be essentially a table with rows and column names and also the row index. So you can access things very effectively. And then we will, I think by default, you need to have CSV format, comma separated value. And I think if you have a table in Excel per se, you can save it. You can save it as CSV file and work with that, right? So for example, you are using Excel now and you say, hey, I don't want to use Excel anymore. I would rather use Pandas. So you can save your file in Excel as a CSV format and provide to Pandas. Okay, so what is data frame? I mean, it looks like this, much like spreadsheet in Excel. I mean, and then what's nice about data frame? Data frame is nice because you store the table so that you can do a lot of nice things with the table, which you will do. And then Pandas has many functions to take advantage of this data frame. Like you can select certain rows, you can combine rows, and so on. So you will see, they're quite nice. And then this is the example, another example, right? So you have rows and you have columns. Okay. Any questions so far? Okay. So we'll be given, you will get some files, and then as you will, I mean, they look like this, right? Like they look column 0, column 1, column 2, column 3, column 4, sample name, some information about samples. So very simple format. Okay. So CSV format is very, very important. Again, I mean, you need to have, at least for this class, you need to have data in CSV format. And then it's often the case. Our data is often stored in the CSV format. And actually, you can save Microsoft Excel as CSV format, but you can do vice versa. You can open CSV format in Excel. Okay. Okay, so and then sometimes it's fine, you know, like I'm not against Excel. Sometimes it's fine to open the data in Excel, especially if it's small one, just to have a look and like, you know, to look at the data. Sometimes it's totally fine. So you can open CSV file. Doesn't mean that you're kind of throwing away Excel away. No, you can still use Excel to look at the data if data is small enough. Structure of CSV file, the same as Excel. You have rows basically and the columns has the names. I think that's the most important. Then you have some delimiter, right? You need to differentiate where the row begins and where the row ends, or the column, sorry, where the columns begins and ends. So you need to differentiate the columns, and people just decided for, okay, comma is a great idea to do it. Okay, so this is how things are. Okay, so a bit more about CSV. Not necessarily very friendly to humans, right? In the sense that, you know, it's if you open the Excel, if you open CSV file just manually as the text file, you will be confused, right? Because commas, and then it's not really easy to differentiate. So one thing, do not use spaces between comma and the value, right? So like, for example, like this. Like you have one column to be control, then you have comma and you put space yes, right? So because space yes will be interpreted as the string like space yes, and you have normal yes, that will be a different string. So if you compare space yes and yes, they will be not the same strings, okay? So be careful that spaces matters, especially for the strings, right? For the strings, they really matter. What is the row identifier? You might have it, right? So if you want to identify the rows, you don't need to do it, but you can. And for example, if you have very kind of like last name of the patients, can be used as the identifier, right? It's kind of like something you can identify. You can identify like the patients, or like sample name, right? You collect a bunch of blood samples, biopsies, and so on. So that information will be identifier because it's everything else is about the sample or about that biopsy, right? So I think sometimes it makes sense, sometimes it's not obvious. Sometimes the data might not have identifier. That's fine. Okay. So how we read CSV files using Pandas? So we do pd.read.csv, right? And then remember, don't forget to import it, right? You need to import the Pandas before you can use it. Okay, so now, because we say PD here, right? We said import Pandas as PD. So we said PD right here. So that's why it will be PD. Now you say PD because you refer to Pandas. You say PD dot read underscore CSV. You're reading CSV file and you provide the file name. Okay, so that's how we would read it. Okay, so actually you can read the CSV file directly from the web in this case. So there's something we stored on our GitHub. Anyways, look on our website, and you can read it just like that. Okay, so you can say read CSV. So instead of like, there are two ways to do it, right? One way is to download the data on your laptop and read it from your laptop. Sure, that's one way. Or another way, it's actually to read it directly from the web. So if the file is stored somewhere publicly, so you can access that, you can like read it directly. Okay, you just need to provide the correct path, which we did here. Okay, so you can do, and then very important thing is df, right? df is the data frame. Essentially, it's a variable. So we say we want to have a variable called df, which will be essentially a data frame, which will store this table, test_data.csv. We would like to have another variable, df2, which will store test_data2.csv. And we would like to have a third variable, df3, which will store another, and so on, right? So you can define as many variables. So now we have 4 data frames being available to us. Now meaning that we can work with them, right? They're available to us. We have downloaded them. In this case, we did not download, they just provided the path. But we have those 4 data frames and we know how to refer to them. So we refer to them by the name. They have the names, right? df, df2, df3, df test. Okay? So that's a very, very first step. So if something goes wrong here, like for example, your format is messed up, you know, you forgot to put column or something, I think you will get the error. You might get the error. Okay, so this is how so what we know so far. We know how to import. We know how to import, and we know how to like define the variable with data frame, right? Load the table into the variable data frame, right? So this is what we know so far. Okay, that's a good start. Any questions? Yeah. Okay, so yeah, so one thing is like, obviously, probably you notice that, right? Like as soon as you make a typo, things are not working. And that's, I think, the biggest frustration when you learn decoding, right? Like any moment you forgot to put the space, or you add extra space, or you forgot to put slash and things like that, you will see like this kind of like scary messages from the computer saying everything is failing apart, right? So why, just like, I think it's like, just try again, look carefully, and try to notice the error, right? So in this case, you can notice that we forgot to put slash, right? And that's the reason it's incorrect. If we didn't put the slash, it's incorrect. The path cannot start with the word, rather needs to be slash first. I mean, that's how Google, like, it's because it's content somehow. They decided to do that. Anyway, so you will get this file that doesn't exist because there is no such a file because you didn't write the path correctly. So what is correct way? That will be the correct way, right? If you download that file, and you can notice here, right? So previous command, you can see that we have download from the web directly. As here, what we did, we downloaded the file, like we downloaded the file from our Google Drive, right? So we download it locally or to Google Drive and then read it. So there are, again, 2 possibilities. Okay, so we can read other formats if you don't have CSV file, but rather delimited by something else, and can be anything, you know, can be like semicolon, certain letter, whatever. You can do that. You just need to say separator, right? So your separator is not comma, but it's something else. So in this case, it's a special character for tab. Sometimes it's tab. In our case, it will be not happening, but it's just for your information. Okay, so something that you can make analogy with Unix, meaning that here you have head, right? Like you remember, like when you display the file in Unix, then you do, so when you do like the head, right? You want to see 10 first lines. Oops, sorry, 10 first lines. Okay, right. So the same here, display, I think 5. Here is actually 5. Display 5 default first lines of the data frame. Right, again, the data frame is so large, typically, that you cannot see it all. You need to see some part of it. If you don't like number 5, for whatever reasons, you say, I would really prefer to see only 3 lines of my data frame. Sure, you can do that, just say 3 in the parentheses. Okay, very similar to Unix, very similar concept. Okay. Okay, so we will do it. You will do it with TAs, where df.head will tell you the data frame, like your table. It's very, very much important to do. And the reason is you want to make sure, again, things are as expected, right? Your table looks as you would like it to look. It's not messed up. The numbers are numbers. You have, you know, like yes, no, everything is like looks good. It's very, very important to check it like this. Okay. Okay, names of the rows, right? By default, it's just like numbers, right? It's like numbers from 0 to whatever, right? That's by default. So there is no really the numbers, but you can change that. So we can give names. And remember that discussion about, do we have such a column which can serve kind of as this index, right? And in this case, it's a sample, right? It's a sample name, because all the information here it's about sample, right? That's why we can say, okay, that's a good index. So what we should do when we read, so actually we should do it if we want something to be indexed. So in other words, if we would like what is called rows to have names, so then we should do that when we read the file, right? So in this case, we say index column, and then index column to be whatever the name, right? And whatever the name of the column. Okay, so summary so far. So we need code-based solution, right? I hope you're convinced by Unix and by whatever we covered so far. You need code-based solution if the file are large, but even for the small file, there is many advantages which keep discussing them. I think notebook environment is great. And then if you're using that in combination of using and the Python, and Unix and the Python, that's a great way to do reproducible and transparent science, right? Like, and then again, coming to this point, it's beneficial even for you, right? Because, like you can revisit your analysis, or let's say you have a new data set, you have a notebook prepared for you, so you can like supply whatever the files are. There's a lot of built data structures. They're powerful, flexible to processing the data. We're gonna learn them. And we can bring other external libraries like Pandas, Seaborn, and so on, right? So that gives the power. And then they are simple to how to work with the data. And then it will be, by data, we mean quite simple data, right? We assume that all the data will be tab delimited. Comma delimited. So we assume that the world is beautiful, like everybody produces the data in the very, very strict format, which is obviously not the case. Data, real world data is noisy, loosely formatted, having missing data sets, inconsistencies, so on. So that makes data science in general hard, that you're dealing with unstructured, often unstructured, poorly formatted data and so on. But in this course, right, like for this workshop or module 2, we assume that everything is beautiful. Life is beautiful. All the data is very well formatted, right? So, and then we would like to learn how to process such data when it's well formatted. So we talked, so just to refresh, so we talked about Csv formats, right? So when we talk about this format, we say, just a refresh, right? So we say that we have this kind of tables, right? The table is just comma delimited. So, and then we said, oh, such a beautiful data structure. We can do a lot of things with it, right? So that's time to do it, right? Just a refresh. So we have rows, which may have names or may not have names. And we have columns, okay? So that's our setup. Okay, so we said, okay, it's a beautiful data structure. What can we do with it? So we can do a lot, and we'll cover few things, just a few things what we can do. So which will allow you to search, right? So to search effectively in this data frame, as well as modify it, right? You can say that you have downloaded the data, and you say, I don't care about all that data. I really care about several columns. So maybe if that's the case, you would like to save it to a new data frame, which is smaller, right? And easier to look at, right? And the same with the rows. You can say that I really need, let's say you downloaded males and females and say, hey, I really want only to work with females or males, just like one gender, right? So things like that. So you will have that possibility. So what is nice, you can access the columns by name, right? So remember, every column has the name, so you can access that by name. All you need to do, you need to say the name of the data frame. In this case is df. So you say df. Yeah, we'll make full screen. So you say df and the name of the column, okay? Like this. And remember, name of the column is the string, right? And then you need to put in the single quotes. Okay, so you can access more than one column at the same time. Sure, you can. So you say df, name 1, name 2, right? So then you will get 2 columns. All right. So if we do df column 2, column 4, that will be our output, right? You can see that we have got a new table on the screen, or like in your notebook, where you see 2 columns, column 2, column 4. Okay. So that was on the screen, right? Remember, anytime you do something, you see something on the screen, right? Like output on the screen. If you need that, you say, okay, that looks great. I would like to have it, right? And use it later. So you would define a new variable, a new data frame, and you call it whatever you would like it to be. For example, df1. So you say the new data frame will be df1, and it will be equal to just 2 columns, right? So if you do that command, you will have a new data frame to work with, df1. If you like to look at that new data frame, you just say df.head, and you will see it. So, okay, that's exactly what I need. Okay. So again, that's about if you got initially very large data, you don't need all of it. You just need fraction of it. So you can do it right away, not to be confused by the number of columns you don't need, right? So clean it in that sense, or select what you need from that data. Then we cannot, so we learn how to remove the columns, right? Or how to select specific columns. So how about we will learn how to add columns? So one question you ask, like, why do I need to add new columns, right? So a few reasons for that. Usually it makes sense sometimes to add descriptor column, right? You would like to have a column which would describe something, right? Describes every row. Or you would like to do some calculations, right? Like you would like to define a new column based on the values of existing columns, right? For example, you have 2 columns, like very similar to Excel, right? You would like to add a new column, which is like the product or the sum of existing columns. Sure, sometimes you need that. So like 2 reasons, right? Like one descriptive, like you would like to describe, or you would like to do some mathematics, right? You would like to do some operation or like product, division, or whatever. Okay, so, and then here, information about data types will be essential, right? So if you do sum, make sure the column 2 and column 4 are some non-string, right? They're numbers. If they're numbers, sure, go ahead and make the sum. If they are not numbers, if they're string, that will be actually concatenation, right? They will be just glued, combined together. Okay, so in this case, you can see column 2 and column 4. Column 2 is numbers, column 4 are numbers. Great. So things will make sense. I mean, things will work. So after running this command, where you say, I would like to define a new column, and you call it whatever you would like to be. In this case, I said column 2, 4. Instead of column 2, 4, the string you see in red can be anything, right? Like any text is equal to column 2 plus column 4. This is how you write it here. All right. So as a result of this line, of this command, you will add a new column 2, 4 in the data frame, in the existing one, df. So, and then you say, okay, did it really work? So the best way, just like visualize it, right? Like look at your data frame and see if things did work as you would expect them to work. So you say df.head. So you're looking at the data frame and you can see, oh, great, there is a new column, 2, 4. Was it correct? Perhaps column 2 plus column 4. Okay, yes, great. Okay, so this is how it works. Very similar to Excel, right? You would make a sum or like whatever formula, and you will drag and drop and so on. So pretty much the same idea. Okay, so concatenate columns, right? If you have 2 strings, you cannot sum them up, right? You cannot combine tomatoes plus potatoes and get, I don't know, apples, right? Will not work like this. If you concatenate potatoes and, I don't know, oranges, it will be potato oranges, right? Those 2 things will be just concatenated, right? So this is what we mean concatenation, when you make a sum in double quotes, sum of strings. make sure both are strings, right? Again, you cannot combine the types, data types, right? You can either sum the integers or you can concatenate the strings, but you cannot combine things. Okay, so let's see. So column 0, 1. So we see that column 0 and column 1 are actually strings. Great. So we can concatenate them. Actually, the syntax will be exactly like you do a sum, right? There is no difference. If you look carefully at this command right here, probably you will not notice any difference with the one we did when we did the sum of numbers, right? It's exactly the same, but the result is different, right? The result is concatenation. So how Python does it? It just knows, right? It knows what is the type. So there is some decision being happening underneath, under the hood, which you don't see. So perhaps Python is looking and saying, oh, both are strings, so I should do concatenation, or both are, integers, then, or like float numbers and so on. So the result will be the result of the sum. Okay, but you don't need to worry about that, right? You just make the sum, and you will see that you got a new column called 0, 1 right here, and you can see there is a control yes, case yes, control yes, case no, right? You got basically in this case we have people who are controlling the cases. Controls people usually with no disease and cases with particular disease, and you have some answer yes or no. Maybe they took a drug or they did not take a drug, for example. And you say, I really want to split people by all those combinations. Are they sick and took the drug? I mean, sure, if they're controlled, cannot be yes, right? Perhaps. Because, right? But you want all the combinations, right? And then you say, for that, I need new column, right? That's kind of the motivation. Now, from the visual perspective, you say, it's very hard to read, right? Control, yes. I would rather have some space, underscore, whatever. So space, don't do it, right? Like don't put the space typically in the string, which is like part of the column, but rather I think the best is like to put underscore, for example. And in this case, this is what we do. So we concatenate, I'm talking about the second command, right? Like we concatenate column 0 plus, we do underscore. So we add another string, right? Since before, very first command, we concatenated 2 strings, which are column 0 and column 1. But we said, let's put something in between, right? It's very hard for my eyes to read it, control yes. I would rather have some space or underscore. So you just put underscore in between, right? You say column 0 plus underscore, or whatever it can be, like any string, plus column 1, right? And that should give you this kind of column where you have control underscore yes, case underscore yes, and so on. It's more visually appealing, I would say, meaning that it's easier to look with your eyes, right, and read it. Okay, so that's just a minor kind of detail, but conceptually, now you know how to make a sum and how to do concatenation, okay? So far, I think very similar to Excel, right? Instead, the only difference, you're just doing that by code, right? Rather than doing that by dragging the column, right? And again, the reason is to work effectively based on code base and also with the large amount of data, right? But theoretically, that can be also done in Excel, I guess, right? Okay, so if statement, like in US, you cannot drink if you're like less than 21, or nobody will sell you the alcohol. So, like if your age is greater than 21, right? You have the variable age in yourself, you have that value. Okay, so when you come to the store, you compare, you do if statement, right? So, okay, my age is 20. Is it greater than 21? No. So it's false, right? The Boolean, false. If it's false, I get Coke. So somebody else comes with the age, and let's say it's 25. You hold this 25, and you say 25, is it greater than 21? True. You get the beer, right? This is what if statement, like informally defined. So we would need that. So we'll use log function to add rows conditionally. Okay, so we say, let's see. So we define, so we ask the question, if elements from the column 0, right? Look at the column 0. This is control, case, control, case. Two possibilities, either control or case. So you say if elements from the column 0 are equal to control, then add the new column called new column 0 and put 10 there. Okay. So this is what we would like to do. We would like to go in this table, row by row, and look specifically at the column 0. If we see here, the very first row, column 0 is equal to control. Great, we put 10 here. If it's case, actually we'll put nothing. So this table, yeah, should be actually like this. Sorry about that. So it should be nothing. Why? Because we don't have a rule for column, for the element case. We only wrote the rules, think like here, right? We only wrote the rules for one kind of arm. Basically, if we do that, somebody comes to the store, and let's say we only wrote the rule when it's false. So nobody will get the beer because the rule doesn't work, right? When we write the rules, they should cover everything. In this case, people who can drink beer and Coke, right? So we need to write the kind of comprehensive rules. So in this case, we just wrote one rule where only if control, we put new column. We put new column to be 10. But if it's case, we don't have a rule right here. Okay. Now, okay, so you see 210, and then here should be nothing because we didn't write the rule. So this is how you write kind of if statement with Pandas, right? And then again, the way you can approach it practically, you need to understand kind of in general what this command does, right? This command have like condition, right? Like it will add a new column and we'll put the values in this new column based on the previous column, existing one. What about the syntax? Sure, you need to understand that, but also you can use it as the template. Meaning, just save this line, and let's say you have your own data, and all you need to change the name of the column, value in the column 0, and name of the new column and the value to be inserted a new column if the value in column 0 is control, right? All those things which are points to, like we have the arrow. All right, so but you can use it as the template. It will, if you do replace everything correctly, it will work for your data, right? So it's quite good command. Now, why do we have double equal sign? So the reason we have double equal sign because single equal sign is already taken, and you have actually used it already. I can show you where. Let's see, right here, right? You have set one single equal sign, meaning that when you define the variable, so you attribute something to the variable. So in other words, you just, let's say, define, to keep it simple, define when you define. So it's taken, right? Define the variable. So see, the single equal sign is taken. You cannot use it. What can you do? Python people decided that let's do double equal sign, and that's quite common across other programming languages. So it said, okay, when we compare things, we ask the question, is this equal to this, right? We compare. So we use double equal sign just to be different from the single equal sign, which is already taken. So that's just very technical detail. But again, you can use this as the template as you analyze your own data, right? You just need to understand what to replace with what, right? So that's fine. That's fine to get started like this. Use things as the template, but just make sure to understand what they do. And you have examples. So and again, you can try it and see, change a little bit, replace 10 by 9 and see if it still works. Probably it will. You can actually put the string here as well. Instead of 10, you can put string and see what will happen, right? So when you repeat what we do in the class independently by yourself, like try to play around, try to replace column 0 by something else, let's say column 4, or actually column 1, like things like that. So try to try to be creative and see how it will work. And then if you got the error, thing is like, why is that, right? Like replace something, change something, say, oh, now I'm getting the error. Like, why is that? Think of what, I mean, like put some thoughts, like think about like, why it's that? Because perhaps you messed up the data types, perhaps you've messed up the syntax and so on. And if you don't have the answer, that's a great question for TAs, right? To come the next day and say, hey, I tried hard. I was really curious. I still don't understand why it's not working. I have replaced a couple of things. Why it's not working? I don't understand. And TA will tell you, okay, perhaps you forgot data type, you forgot this, right? So that's a great kind of, that's what programming, again, coming back to this question that you can do a lot of self-learning in programming, but just playing with the commands, right? Being curious. I think being curious, what will be if I change this? Like, for example, what will be if I do single equal sign instead of double? Probably will not work, but check. I think you can do that. You can just change something and see what will be the output. And if you don't understand, you have TAs to ask the question. So that's a great exercise, kind of like self-learning exercise. I would really encourage you to do that. Okay, so what was the problem with this? So when we write this kind of command, we only cover one type, one case. When things are controlled, how about the cases? We don't have a rule. So if there is no rule, we'll put an A value, so like missing value, because there is no rule. So what do we need to do? We just need, again, I'm not giving you complex data structure. So whatever, like complex command. We will survive with 2 commands. Perhaps somebody with more sentiments for the beauty of the commands will say, no, that's ugly. That's ugly. Or like, that's not appropriate to do 2 commands for if statement. Why don't you write 1? So the reason I did not write 1, which we could write a single line for both cases, just to make it simple. I would rather not to confuse you and give you something extremely simple than bring something complicated. So look here. So what we do, we cover control and look at the second line of code, like right here. It's actually absolutely the same, except 2 things. We say case here. So we say when we go through the file, if the elements from the column 0 are equal to case, then new column will be 9. That's it. If you have more than control cases, let's say you have case, control, and something else, just write another line of code. Okay, so as many cases as you have. So in this case, then it's nice, right? Instead of missing value, remember, instead of 9, it was missing values. Not anymore. Now we have 9. Okay, so I would say that's perfect, right? Assuming that the column 0, we have only control and the case, those 2 lines will be sufficient to define a new column. Okay, any questions so far? Okay, so hope that makes sense. Okay, so now let's talk about how to select rows from data frame. Okay, so what we are trying to do. So we say again, the data frame is too large, right? I mean, the data I have got is too large. I don't really care about the cases. I just don't. I really only need controls. Let's say I need healthy population. I don't care in this particular study about people with the disease. I really want controls. Sure, that's a good question or whatever. That's a good motivation. So how you select that automatically? So what you say, kind of very similar. So you say, like you use the same log function and you say df column 0 are equal to control, right? So you say df log df column 0 is equal to control. Say, okay, so meaning that you only selecting the rows which are controls. What that means? You select, in other words, you're selecting the rows which have element in the column 0 equal to control. That's what means, like we're selecting rows, control rows, okay? But here, actually that was a great question before, we're actually not changing the original data frame. df is not changed. Instead, you're getting the new data frame on the screen, right? And to save it, you would need to like, we'll see in a second, we'll save to some new data frame, right? So this command, in contrast to the previous one, is not changing your data frame. Instead, is outputting you on the screen some new output. Okay, so we'll get in a second how to save it if you need it to use. So we can actually not, so like, look here, right? So this was strings. And remember, with the strings, you cannot do much. With the strings, you can say, as I mentioned, right? You cannot compare. This string is larger than this one. I mean, technically you can, but doesn't make really sense, at least for daily life. I mean, for whatever purposes you do. So all you can do is typically you say, is column 0, is elements from the column 0 are equal to some string? Are they equal? And that's why double equal sign. Don't forget double equal sign. Are they equal to each other? Yes, no. True, false, right? That's it. Not much. If it's number, yeah, you have more flexibility. You can ask the question, is it greater than 1,000? Less than 100? I don't know. Less than -5? Like whatever. It's more flexibility. So here we say, if the elements from the column 2 are greater than 0.5, then output, right? So in this case, you can see that we look at the column 2, look here, and though all of the numbers in the column 2 are supposed to be greater than 0.5, right? This is what we asked to do, and this is what was the case. All right, so you can, so that's like initial cleaning or modification of the data, right? As you got the data from somebody or from public sources or from somewhere, you can modify it in a way that it's convenient for you, right? For some reasons you can do, you will need, you might need to do some filtering or cleaning like this. Okay, so data types. So you can actually look at the data types of your columns, right? And then it's a very simple command, and it's df type d type. Okay, as soon as you type it, this command, you will see this kind of output on the screen, and this output will let you know, like is it like where you have numbers and where you have like in this case, I guess, let's see, column 0 is what? Column 0 is string, column 1 is string, column 0 is string, column 1. What about column 2? Yeah, so basically I think the way we created, or maybe it's a different one, sorry, maybe it's a different one. So anyways, so you will see the data types and then of each column, right? So, I mean, you can judge by eye in a sense, but also it's a good idea also to check it formally. Okay, so let's see. So another thing what often occurs that you have, like some non-numerical values, right? You have a column and suddenly let's say there is a typo, there is some, I don't know, some issues that you have some value there, which is which is not number, right? And you say, okay, what should I do about that? I mean, typically you can clean it, meaning you can remove it, right? And that's or kind of more kind of formal, I would say you first need to convert all non-numeric values to none, not available, right? So anytime you see non-numerical, you replace it by none, and then you decide what to do, right? You can keep it as a none, fine, maybe, or just if you're required, you can remove it. You can, and then you can, meaning when you say I remove it, you remove the entire row, right? So you're losing the data in a sense, right? You say, since I don't have the value I need in the certain column, I will remove the entire row because it's useless, let's say, right? Okay, so let's see. Okay, so we're looking at the column 2 here. So let's look. So this is our column 2. So we have some numbers, and then we have some non-numerical value. And then, and what we do, we set, so in this case, like this is how we say it. So we try to convert everything to numeric, right? Like we look at the column 2, right? And we try to convert it to numeric. However, if it fails, if we cannot convert, this is why it errors. If we cannot convert to numeric, then we say none. And this will be the output. So here was some non-numeric value. Let's say somebody did typo instead of dot, forgot to put the dot, something, anything. Anything can be there. So we replace it by none. And actually, when you will work with TAs on this data, I think you can look for the original. I just don't remember what is inside. So you can look for the original file and see what was inside, why it was non-numeric. We have some typo, which we did obviously intentionally, just to have this case. Okay, so we got none. Okay, so then this is our output, right? And you say, okay, I replaced some non-numerical value by none. That's your first step. The second step, you try to clean the data based on none. You say, I will drop all nones. And then the command is very kind of clear to understand, drop NA, right? So like not available, right? NA. So you're dropping the entire rows where you have at least one NA in column 2. If in column 2 you have NA at any given point in any given row, you will remove the entire row. Okay, so and that will be the output, right? Like after running this command, and you say df. In this case, you say I want to use the same data frame. For example, in another scenario, you can say I would like to keep df as this table because I need it for some reasons, but I would like to define a new data frame which will be a clean version of df. Sure, you can. In this case, you need to replace df by some new variable. Okay, but in this case, we decided, you know what, we don't need original data, so we'd rather replace it. So now df, our data frame, will look like this. And you can notice perhaps that sample 4 is missing, right? We don't have sample 4 anymore because we decided it's not good enough just because it's having no values in the column 2. Okay, we said that's not good to us. Let's drop it. Let's remove that entire row. And this is what we did. So that's our new data frame, which does not have any NA values. So it's clean and good to go, at least in terms of column 2. Okay. So there are a few possibilities how we drop. So it's not that straightforward. It can be a little bit more kind of ideas there. So we can drop all the rows with at least one NA and none value. Then we can drop only the rows entirely composed of NA, meaning the entire row is NA, and so on, right? We'll see. Or maybe we fill NA with some value, like zeros, or 1, or whatever, right? So we have a little bit flexibility here, how to deal with that. And let's see. So drop all rows entirely composed of NA. This will be like this. df equal to df dot drop NA. How? You ask how? How do you want to do it? How do you want to drop? We want to drop all, meaning that if there is a such row which is composed entirely of NA, we'll drop it. So what will happen to our data frame? Nothing, right? Because we don't have any row composed entirely of NA. Not in our case. So this command will not affect our data frame, right? Why? Because again, there is no row composed of all NAs. Okay, but that can be the possibility, so it's good to know. Then drop all rows with at least one NA value. Okay, so what will happen? You're looking at the data frame and you see a single NA. You say, okay, drop this row. Like I don't like it. Even one NA is not good. Fine, we actually have that case, right? Remember, we have sample 4 where there is one NA. Will be removed. Another possibility, you say, you know what? I think I would like to replace an A by 0 or whatever the value. You can do that. You say df fill NA, like fill, replace. Fill NA with 0. Put the 0 instead of an A. Fine. So now formally, right? Formally, maybe this is not great idea in terms of statistical analysis or whatever analysis, but formally, from the data perspective, you saved the row. Sometimes it's crucial, right? Sometimes it's crucial to save the data, not to throw it away. And then you somehow you have internal knowledge or domain knowledge that 0 will be appropriate here. So great. So just on the note, when you do this kind of things, right, when you assume things like this, I mean, first of all, you need to be sure that you're doing correct thing, but also when you write the reports or papers or publications and so on, it's a nice idea to have a method section and actually say that and say why you're doing that. And that's why it's important to share the notebook, which can be accompanying your report or manuscript or publication, anything, where people can see what you did exactly to clean the data, right? You start from the very beginning of your data, and then you say what exactly did you do, and people can see what kind of filtering and cleaning did you do. Okay. So sometimes you have, again, remember I mentioned to you that real world data is not kind of as beautiful as we think it is in terms of formatting, right? It's sometimes messy. So let's kind of get some sense of it in a way that let's assume that the data you're dealing with is actually coming from different sources. I don't know, let's say you have some patients and then one doctor did a table, you took it, or some institution, and then actually another institution was responsible for something else. So you got like multiple tables across. Now you can okay, that's not a problem. I will just concatenate it, like glue them together. Yes, that will be beautiful, but if number of samples is the same and they are ordered the same, right? Like you have 10 samples, sample 1, sample 2, and so on, 10 here from one doctor, and let's say the same 10 samples from another doctor, and you combine them. You just glue them together because they're sorted exactly like this. Great, that's true. However, maybe one doctor, one institution is missing the measurements from one sample, so they decided to drop it. How about that? You have sample 1, sample 2, and so on, sample 9, and this one, only sample 1 is missing, so sample 2, sample 3, and so on. Okay, when it's 10 is not bad, but think about like there is a mess, like there is like 80% data here and 75 here, you need to merge it only based on the sample in common, or maybe you want to put missing values. You still want to take sample 1 and put whatever the measurements from the doctor 1, but missing value from doctor 2. Maybe that's what you want. So there is more than that. So it's kind of some proxy of how complex data merging and data formatting can be. Some proxy of it. Okay, so that was motivation. So how we do it? And then let's define exactly what we would like to do. So we would like to have 2 data frames given to us, right? This is what it, and with related information. What we mean by related? That some object results, they share basically a column. This is what we mean related, right? They share the column based on which they can be connected. For example, sample name, patient name, patient ID, whatever is that. And then to make it complicated, which is like sometimes happening in the real world, some subjects can be only present in one data frame, but not another one. And we can choose to include them or not. The only requirements, the column named with subjects, meaning patients, for example, should have the same name. Otherwise, the Python will not know how to merge them. Okay, so this is the problem. Let's see. So let's say we have those 2 columns. Those 2 tables. So table 1, have some information and we have sample name. And actually somebody else gave us another table and say, oh, I also have the age. Can you please include it? Okay, but there is slightly problem there. You don't record the age for everybody. You actually recorded for everybody except sample 2. Somehow you don't know. Okay, so this is the data. So again, gluing will not work, right? Because they have different kind of set of samples. So what we can do? So this is the data you will be reading, right? So again, you can read directly, remember, from the web, from the internet, from our repository. So you will get the data with TAs. Okay, how to merge? So what we need to say, we need to give a new data frame, and the new data frame we would like to contain 2 individual data frames. Okay, so we say merge. Okay, makes sense, right? We would like to merge them. So then we say df, data frame number 1 here, and df2, data frame number 2. 2 data frames so far, okay? We want to merge df with df2. How we would like to merge it? We would like to merge it on sample name. So we'd like to consider sample name, and based on that, we would like to merge it. That's a column name. So if we do that, you can notice that by default, we don't have sample 2. So why we don't have sample 2? Because it was missing from df2. So by default, it's thrown away. Okay, because we don't have information of age for df2. So that's why Python decided to drop it. And that's your new data frame, by the way, where you have, where you have age, right? So now age is part of one data frame, right? So we have integrated. If we have another one, we can take another one and do kind of the same procedure and keep adding things until we have a complete data frame to work with. So let's see. So so we got a new data frame, right? Where, remember, sample 2 was dropped because it did not have the age, but the rest survived, and we have now the age. All right. Okay, so actually there are more than that, right? Like that's one way, and actually that's a default. But there is more than that, in the sense that we can take only rows identified that appear in both data frames. And actually this is what we did, right? Take only rows identified that appear in the left data frame. And when I say left and right, by the way, I mean this is what? This is right, and this is left, right? I mean, just like looking like at it, right? So df is left, and df2 is right. Take only the rows identified that appears in the left data frame. Take only rows identified that appear in the right data frame. Take any row identified that appears in either data frame, the union, right? So 4 possibilities. And let's see how that works by example. I think we'll have examples. Okay, so take only rows identified that appear in both data frames. In other words, sample 2 need to have information in both data frames. And actually that's default. This is what you already did, or like I have shown you how to do, right? That's a default. So if we say how, inner, and those are keywords. Actually I don't have them here. Interesting. Okay, so yeah, but you can look here. Okay, so inner, that's a command, and that will be, I mean, you don't need actually to type it because default, but just like to show how it works. So it will be exactly the same as default, right? Because that is actually the default. Okay, so we saw that already, right? Sample 2 was dropped. Okay, so now that's left and right, just to make sure we're on the same page. So take only rows identified that appear in the left data frame. So we'd like only to take the ones which appear in df. Okay, so df was here. So we'll get sample 2 included here, right? But we don't have information for age, so it will be none. Okay, then we can take any row identified that appears in either data frame, right? So we take the union. Okay, so we take all the samples, in other words. We take the samples present in df and df2. And again, just because we don't have age for sample 2, that will be none. Okay, so what will happen if you have, let's see. So what will happen if you have, I'm just trying. So what will happen? I mean, what are the requirements, right? To merge, to have a merging, right? To be able to do merge. So we should have at least one identical column, right? Based on which we can merge. So in this case, it was sample, right? So based on sample, we merge. So what will happen if we have more than one identical column? Okay, so let's see. Okay, so sometimes you can just figure it out, right? Create such instance where that will be the case and see what will happen, right? So we have age, sample name, but we also have one more identical column, which is column 1 here, and you have column 1 here. So you can see that both data frames, they share more than one column. They share 2 columns, okay? So let's see what will happen. So, and that we're trying to do, right? So what we're trying to do, we say, okay, we would like to merge and we would like to merge based on sample name. Great. So that is sample name is the required column, right? Is the column required to be shared, but the Python didn't expect more. So what it does, it notices that there is a column 1 being shared between 2 data frames. So it will handle it like this. It will create duplicated column. It will say column 1 underscore X and columns 1 underscore Y. Okay. So, so what you need to do? One, I mean, usually, if that's the case, right? Because remember, data is given to you, right? Of course, you can manually clean it, but probably not. You should not do that. You can do that in Python. So you should look at the data and look to see if you have duplicated column and just include it here, right? When you merge, remember, when you merge, you say, before we said just one column, but if you had duplicated columns, more than one duplicated column, so you just add it there. You say, I would like to merge both on sample name and column 1. Okay, and then as you do that, you will not have a duplicated column. So why duplicated column is a problem? Because actually they're renamed, right? So you have, I mean, first of all, it's not nice. I would say it's kind of weird to have duplicated column, but more than that, they're renamed. So if you have some code later working with the column 1, it will not work because there is no column 1, but there is column 1 underscore X and column 1 underscore Y. Okay. Okay, so I think we'll stop here and we'll have a couple of slides.
Yes, I have a question. What does happen if we have some different values in the identical columns by any era when it was introduced, data was introduced in the...
Yeah, I think it's like, it will be like this. It will be, you mean here? Yeah, yeah, so if you have different values in column 1 when you run this command, so I think column 1x will be different from column Y, right? It will be different. But actually here, I think it will show you the error because it's assumed, because you're merging on them, so they should like be identical. So I think, yeah, you probably will get the error.
Thank you.
Yeah, you can try. I mean, maybe with TAs, maybe you can try that. You know, like you can modify the file and see what will happen.
Yeah, of course. Thank you.
Right. So we said that we need to avoid duplicated column, but if we do have duplicated column, okay, so I need to admit. So, but if we do have duplicated columns, right, then we need to provide all of them here, right? So we actually need to have one duplicated column, right, across 2 data frames. So this is how you can merge 2 data frame, okay? So, but if you have more than one, then you just need to put them here. Okay, so this is what we have done. Well, this is why we stopped yesterday. So we'll have another like 10 slides or so. Okay, so let me do full screen, perhaps. Okay, so if we need to reset the index, right? So what is, remember, what is index, right? So columns need to have names, right? Like in this case, you can see column 0, column 1, column 2, column 3, and 4, right? Those are the names. I mean, in real life, that will be something more meaningful, you know, like let's say age, biological sex, like things like that, right? So those are the phenotypes we typically collect, let's say for the patients, or the phenotypes of the samples, right? So we do that. Now, remember we discussed for the rows, it's actually kind of optional to have names, right? And why is that? Because maybe there is no such a column which can serve as names, right? So in this case, we know that all the information we have in this particular table is actually about samples, right? So it's kind of makes sense to group things around samples, sample names. So this is what we did. So you can see when you print df hat, right? You look at the first lines of the file, so you can see that the column, which is sample names, actually looks different, right? The reason is look different because those are the names of your rows, right? So that's your index. So this is what we will call this your index. So if you would like to change it, right? So you can, for example, you say I don't want to have an index. In other words, you say I don't want to have names for the rows. Sure. So then you need to run this command. So you say df is equal to df.reset index. So basically say, okay, remove the index. I don't need it anymore. Okay, so if you do so, then you see there is no index left anymore, right? So in other words, again, there is no names for the rows anymore. Okay. And then you can do it back, right? To do it back, you say set index. And you provide sample name, like the name of the column, or maybe different column name, right? If you would like index to be something different. Okay, so this is, so you can at any point in time, you can remove the index by using reset underscore index, or you can set index. So you can go one way or another, okay? So that's again, just for convenience. So to have the index, and sometimes again, sometimes it's possible and sometimes it's not. Okay, so sometimes you need to group rows by some categories. So what do we mean by that? So often we want to group rows together for some group calculation. For example, you have a huge table, and let's say you have people, I mean, you have patients, which are obviously some of them are females and some of them males, okay? And we say, okay, so we know how to compute mean, right? The average across, let's say, age, across the entire population, including males and females, like everybody. But we say, okay, but we're also curious to know, are there differences, do we have a differences in age across males and females, for example? Or do we have differences, I don't know, in blood pressure across males and females? So you need to group, right? You need to group your data first by some categories and then do some calculation. For example, you want to compute the mean, the average, okay? So that's very often. So, and if you would like to group, so this is usually straightforward when the groups are well defined, like in this case, males and females, right? But however, if you have numerical values and you want to group by that, that's less straightforward, because first you need to define the threshold. By threshold, we mean like some number which will differentiate the groups. So for example, you talk about like blood pressure. So you want to categorize people into low blood pressure and high blood pressure. So you need to come up with some number, right? So before that number, let's say we consider blood to be low, I mean the pressure to be low, and then above that number to be high, for example. So we need to know the number first. So, but then we also need to define a new column, which will basically say, which will be categorical column based on the condition. So we will say if, again, like we will just have a name, right? Like low pressure and high pressure based on this calculation, based on the threshold. So let's see some examples. Okay, so let's say we have age, right? So we want to split people into age greater than 25 and I guess less than 25. Okay. So, oops, sorry. Wait, did it move? Okay, so we want to split people, right? Greater than 25 and less than 25. So then what we would like to do, simply saying we would like to add new column, which will have two strings or two names. We'll say GT10, which is age greater than 25, and LT10, which is age less than 25. Here, it's just abbreviation. You can say anything you would like, right? That's just a string which you invent. You know, you can say what is convenient for you. So, right, so we want that to happen. So this is what we want our output to be. So maybe let's start kind of reverse. Let's start with the output. So what we would like to happen. So if you look row by row, as the computer would, looking at column H, you can see this is 25. So it's not greater than 25, right? 25 is not greater from 25. So that's less than 10, right? So the reason is just because we use strict greater, but not greater or equal. Okay. So that's why SLT 10. But 55 and 33, they're actually greater than 25, clearly. So that's why GT 10, right? So this is what kind of our logic is, right? I hope that makes sense, right? So we're adding new column based on age, categorical one. Okay, so this is what we would like to happen. Now, how we do it, right? So we need to write this kind of command in Python in order that to happen. So let's look more closely. I think some things already familiar to you, like log function, right? We have used it before, and accessing the particular column. So we know how to do that, right? To access the particular column in the table or in data frame, you just need to refer it by name. Simple enough, right? You say, dear foo, this is our data frame, and you say, which column do you want to refer? So we are referring to H. Great. So we would like, so we say if the elements from that column are greater strictly than 25, then we would like to define a new column, H_cat, and we would like elements in that column to be GT10, only if H is greater than 25, right? So we write like this. So, but then again, that will be not enough, right? Because it will be covering only the cases when it's greater than 25. How about less or equal to 25? So we use exactly kind of precisely very, very much similar syntax. So again, like the way you can take it for now, I would say, like don't worry about the syntax. I would say, like I will never, at least now at this stage, will never ask you to like write it by heart, like memorize it and wake you up in the night and check. No, that will be not the case, right? So all I think you need to know how to modify to work for your data, right? So we take kind of step by step. So we'd like you to be able to modify this command and to understand what it does, but also to modify so that it works for your data. So let's modify this command, right, to work for the less or equal to 25. So what we need to change? So perhaps we need to change greater than 25, right? We need to change that to be less or equal to 25. Okay. How about HCat? No, that will be the same column. How about H? Stays the same. The only difference here, GT10. So, right, so since it's less or equal to 25, we need to say something else. And we decided to say LT10. So that's exactly, if you look here, that's exactly what we're trying to do. We're trying to say less or equal to 25 and LT10, right? So I think that's all you need to know how to add conditional column, right? So as the new data comes to you, or you say it's no longer 25, 10, you can change it, right? That's the purpose. So I think working with TAs to make sure you're able to modify this command for your data, that's what you need, all you need for now, right? You don't need to memorize it again. There is no point, at least now, to memorize it. Rather, spend time to understand it and be able to modify. And that's kind of refers to everything we'll be doing here. Basically, you will always have slides in front of you when you do the assignment or when you do the homework or like when you do anything, right? So it will be, and then TAs are working to prepare some kind of like summary for you, like cheat sheets, like so you will have all the commands. So they will share that soon. So so don't memorize at least now, but as you practice and practice, you will actually memorize it anyways. But don't do it intentionally.
I do have a question, if I can ask.
Sure.
If we run only the first line in the code, what will be added in the age category if people, for example, if we run only the condition with more than 25? In the other category, like the other rows will be NaN, not numbers?
Yeah, NaN. Yeah, I mean, if you're not covering some cases, right? So it will be NaN, right? It will be not available. Yep, exactly.
And if we have already data, for example, if we write something and we have already data, it will be replaced?
Oh yeah, that's a good question. I mean, I never tried. You can try, but I imagine, yes, it will be replacing. I don't think you should get the error. New category, I hope.
I think you could just try it and run it, but
yeah, you can try and run it and see. Yeah, I'll ask TAs. Actually, that's a good question for TAs. They can kind of help. I mean, they can show you what will happen. Actually, yeah, I never tried, but I imagine that you will not get the error, like error, you will not, but rather like you will be replacing the values there. Yeah, but you can, I think things like the best way to answer this question is just to try. And TA, I mean, if you ask this question, TA, I'm sure TA will help you to kind of like try that and see what will happen.
Yeah, thank you.
Sure. Okay, great. So, okay. Now, as we have that column, right? Oops, sorry. Like this one, right? hcat now, which is the column we can split the people. So the whole purpose of creating that column was so that we can split the people into two categories or more, right? Easily. So, okay, but this is, as you can notice, column 0 is that kind of column already. So you have two types of samples, right? Case controls. And actually the same for column 1 is yes or no. So you can compute a mean for each category, right? You can take column 0 on the controller and compute the mean of that for any column. Let's say for column 2, you say, what is the mean of control for column 2? And you can compute that. Okay. So now, but first we need to group, right? So we'll use the group by function, which will group all the rows based on the values in certain column. So in this case will be column 0. Remember case control? So we like to group and compute the mean. For example, mean is the average, right? Just making sure. Okay, so we can do that, and we actually can define a new data frame for that. So you say new group, new data frame equal to df full group by column 0 mean, and you just print it. So what you see now, that for every column which is numeric, right, you have grouped people and you have mean. So actually mean of the column number 3, in this case for cases, are 0.3. And mean for controls for the column 3 is 0.165, right? And so on, right? So you have grouped your data into two parts, case controls, and you have means for every single observation you have. Okay, so sometimes it's quite useful. Okay, you can group on the multiple columns, meaning you can take all the possible combinations, right? So exactly the same. The only difference, you just add two columns here, column 0 and h_cat category, the one we created previously, right? Two columns. So then you get all possible combinations. So you have actually 3 combination. I guess we never got control and GT10. That's why it's not displayed. But in theory, you should have 4 possible combinations. So you have case GT10, you have control GT10, and you have control LT10. And for each, you have the mean, just right, because we have asked to compute the mean. Okay. And you can have as many combinations as you would like, right? You have like, let's say, the most typical example is like female, I mean, biological sex and age. So you have, like, like let's say, elderly males, elderly females, younger males, younger females, and so on, right? So like you can have all those kind of categories combination wise. Okay. So that's pretty much everything I want you to know about Pandas. That's like just like tiny bit of what Panda is capable of doing. But the point is you to be able to use it, right? So you can spend the rest of the time like you have for independent work just practicing that. Look. But that will be solid foundation to do some very basic stuff and get sense what Panda is capable. Okay, so after you're done with analysis, like you have produced new data frame which you like, meaning that you want to save them and use it later, maybe copy to your laptop, open in Excel, like whatever you would like to do with them. You can you know, like you can write them to CSV file. And then it's quite simple. So you just need to say name of the data frame you want to save. And you save to CSV. And you say just where, right? And since we're working on the Google Drive, you know, like they will be saved on the Google Drive just because we work with Collaborative, right? So they will be on the Google Drive, which you can save later on your laptop if you need, right? And you say the name of the file and the file will be created for you, right? In this case, we say, okay, we want test underscore data underscore full. Okay, so that's how you will save what you have done. You know, you have transformed the data, you have extracted novel information and so on, right? And you will save it to use it later. That's always a good idea, obviously, you know, like to save the results you have done. All right. Yeah, so this is how you would save. Like, let's say you have grouped by, right? Like, remember, you have computed the mean for different categories. So you want to save it. And then you can just doing this. And what you expect to see in your Google Drive, new file to appear. I think you can open it directly on the Google Drive. It will be not that friendly because, you know, visually, because it will be comma. But that's okay, you know, like you can transfer to your laptop and open in Excel, for example. Okay. So, okay, so I think you will do that with TAs. So using Pandas, yeah, I think that's, then we can skip this. I think you can do with TAs. Okay, great. So I think that's pretty much all I wanted to tell about Pandas. I mean, we'll use them in a second, actually, when we're gonna do visualization, but like Pandas standalone, I think that's all we have got. And again, that's just very essential. So like, you know, like moving forward, as you do in the dependent project and like in general, you know, like you can self kind of educate yourself and like if you need more, but sometimes you can survive with those, like what we did, 20 or so, and maybe even less commands, and it's already, you can do a lot with them. Okay, so any questions?